All right, in the next two sections, we are going to take a look at all different kinds of trigonometric equations. But in 6.5 part 1, we'll start with some basic ones. All right, so I just have sine of x equals the square root of 2 over 2. And my goal is to solve for x. Now, x is an angle in this case, right? If we're taking a trig function of something, that's going to be an angle. So what we want to do is look on the unit circle to see where sine is equal to the square root of 2 over 2. Now remember, sine is the y value. So that occurs right here and right here. So those angles are pi over 4 and 3 pi over 4. So those are my answers here. Okay, x equals pi over 4 and x equals 3 pi over 4. Okay, now there's a little bit more to it. Now, I should point out, this question does say express your answer in radians. Okay, sometimes it'll ask for degrees, and in that case, we would say 45 degrees and 135 degrees for these. But now, technically, I could, from this angle, I could go all the way around the unit circle and come back here, right, to this coterminal angle. So I could say that if I added a full rotation, if I added 2 pi to this, that would also be an answer. So 9 pi over 4 could be an answer. And if I go another full rotation and end up back in that same spot, add another 2 pi on, right, that would also be an answer. We could do that an infinite number of times. And we could do the same thing here. I could go 2 pi, come back to here, go 2 pi again, and those would all be answers. And even we could even go in the opposite direction, right? We could subtract 2 pi and go for negative angles. So there are infinite answers here. We can't list all of those answers out, but what we can do is say, well, I'm going to add on 2 pi times some integer. Now, whenever we see an n, that's just assumed to be an integer. So this is how we express all of the answers, right? We say we're going to start at pi over 4, and then we could go 2 pi however many times we want, right? We could go around the unit circle a million times, right, and get that many different answers. So for all of these answers, we are just going to tack on a 2 pi n, right? That expresses all of the possible answers. All right, let's do another example here. So cosine equals the square root of 3 over 2. All right, so cosine is the x value. So positive square root of 3 over 2 occurs here and here on the unit circle. So that means that my two answers on the unit circle are pi over 6 and 11 pi over 6. But remember, we could go around the unit circle however many times we want. So what we need to do is add those rotations on. So we just say plus 2 pi n and plus 2 pi n. Okay? In these next two examples, these are the same idea. It just says express your answer in degrees. Now, on the unit circle, we have not really memorized the tangent values, but remember, tangent is sine over cosine. So I want to see where sine over cosine equals -1. So we're going to have the same thing over the same thing. Just one of them will have to be negative, right? And that's going to occur right here, right, at 3 pi over 4, or in this case, we're looking at degrees. So at 135 degrees, because if I think about sine over cosine, I'll have negative square root of 2 over 2 over square root of 2 over 2. That would just reduce to -1. Now, tangent is slightly different because tangent repeats every 180 degrees, right? Sine and cosine just repeat every 360 or 2 pi. Tangent repeats every 180 or every pi. So there's actually another place on the unit circle where this would happen, right? Where tangent would be -1. It would also occur here at 315. Now, there are two ways that I can write my answer here, okay? And I will accept either of these answer forms. Either of these would be correct. So I can say that, well, one place on the unit circle where this occurs is 135. And now, if my answer is in degrees, instead of saying plus 2 pi times some integer, I'm going to say plus 360 times some integer. Okay, it means the same thing. We're just expressing one of our answers in radians and the other in degrees. And then I could say, well, the other place this occurs is 315 degrees, and then plus 360 times n. But another way that I could express this answer, and again, this only applies to tangent or cotangent, but we're really just going to focus on tangent here. Another way that I could write this answer would be 135 degrees plus 180n. This form of the answer actually includes 315. Okay, if I were to add 180 to 135, I would get 315. So if we can remember that tangent repeats itself every 180 degrees, we can simplify our answers for tangent. Okay, now this form of the answer actually means the same thing as this. Okay, this is just a little bit simpler. All right. So this other one, for expressing our answer in degrees, we actually have one step that we need to do before we can look at the unit circle. Okay, whenever my trig function is not by itself, I need to take care of that first. And that's what's going to happen in the next few examples, right? So here, I would need to add 1 to both sides first. I need to get the trig function by itself. So that will become sine of x equals positive 1/2. So now, once I have the trig function by itself, then I go to the unit circle and see where sine equals 1/2. So sine is the y value. So that's going to occur here and here. And if I'm expressing my answer in degrees, that's going to be 30 and 150. So my two solution sets will be 30 degrees plus 360n and 150 degrees plus 360n. Right? We have to use our two solution sets when we're talking about sine and cosine, because if I were to just add 180n onto 30, I would be at 210. That is not one of my answers, right? So the 180 idea only applied to tangent. Whenever we're looking at sine or cosine, we have to use the 360 or the 2 pi, all right? So the last two examples here ask us to just find solutions in the interval 0 to 2 pi. Okay, so that process is going to be the same. We'll just have one extra step at the end. Okay, so let's go through this one. So again, I need to get my trig function by itself first. I have a 2 outside of it, out in front. So the first thing I'm going to do is divide both sides by 2. And I'll get cosine of x equals negative square root of 3 over 2. So again, we want to go to the unit circle and see where cosine, which is the x value, is negative square root of 3 over 2. So that's going to be here and here. So my values would be 5 pi over 6 and 7 pi over 6. So 5 pi over 6, and then make sure we tack on our plus 2 pi n, and x equals 7 pi over 6 plus 2 pi n. Okay, so now we're only concerned with the values on the interval 0 to 2 pi. So what we want to think about is plugging in values of n, plugging in integers, and seeing what values we would get that are in between 0 and 2 pi. So here, if I plug in 0 for n, right, that'll be 5 pi over 6 plus 0. 5 pi over 6 is in between 0 and 2 pi. So that is one of my answers. So I'm just going to collect my answers down here. Right? Then if I plug in 0 here, 7 pi over 6 plus 2 pi times 0, 7 pi over 6 is also in between 0 and 2 pi. Okay? If I plug in 1, right, we'll have 5 pi over 6 plus 2 pi. Well, if I convert this or get common denominators, right, this would be 12 pi over 6. So 5 pi over 6 plus 12 pi over 6 would be 17 pi over 6. 17 pi over 6 is not in between 0 and 2 pi, so that is not going to be one of my answers. And I can clearly see then that this one, if I add 2 pi, will also be outside of my 0 to 2 pi. So my two answers here are 5 pi over 6 and 7 pi over 6. Now, for a problem like this one was fairly simple, that we probably didn't need to go through this process right here. We can just kind of look at the unit circle and see, well, if I'm at 5 pi over 6 and I add 2 pi n, I'm going to be outside of that 0 to 2 pi range. Same thing here. Okay? I just want us to get in the habit of looking at a problem like this because we will get to more complicated versions that will require us to plug in multiple values of n, and we could get 5, 6, 7, 8 answers down here. Okay? This is certainly a simpler version where you probably don't need this step here. All right. Our final example has a subtraction inside of the trig function. Okay. Again, we're only looking for values on the interval 0 to 2 pi. So my first step is to get the trig function by itself. So I'm going to subtract the 1 over. We'll get 2 cosine of x minus pi over 4 equals 1. Divide both sides by 2, and we'll get cosine of x minus pi over 4 equals 1/2. Now, my trig function is by itself, okay? Even though I'm subtracting something on the inside, all I really care about is getting the trig function by itself. So now I can go to the unit circle and say cosine equals 1/2 right here and right here, okay? At pi over 3 and 5 pi over 3. So now this is the key here, right? Since I've got x minus pi over 4 on the inside, I need to take that whole thing on the inside, x minus pi over 4, and set that equal to my angles, pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. Okay, now I actually have one more step. Okay, to get x by itself, I need to add pi over 4 over to the other side. So now, since I'm adding, right, we can think about these as just like terms. I don't need to add pi over 4 to both of these, right? So pi over 3 plus pi over 4, well, I need common denominators. So I can come off to the side here and say that pi over 3 would be 4 pi over 12 plus pi over 4 would be 3 pi over 12. So that would be 7 pi over 12. So here I can say 7 pi over 12 plus 2 pi n. And then here, 5 pi over 3 plus pi over 4. Well, again, common denominators would get me times 4 would be 20 pi over 12 plus 3 pi over 12 would be 23 pi over 12. Now, we need to be careful here, okay? This 23 pi over 12, it does still fit in between 0 and 2 pi, right? Because 2 pi, if it with a denominator of 12, would be 24 pi over 12. But we could run into a case where this value would end up being outside of the 0 to 2 pi. And we'll take a look at examples like that in the future, but we want to make sure that that value still fits what we want to look at. Okay, so now, since I only actually care about values between 0 and 2 pi, well, if I plug in 0, I'll get 7 pi over 12. If I plug in 0 here, I'll get 23 pi over 12. All right? And if I plug in 1, if I add 2 pi to that, I can clearly see that adding 2 pi to this would be outside of my 0 to 2 pi interval. So these are my solutions. Okay, so the only difference on this one with our previous ones was I needed to get the trig function by itself and then set the entire inside equal to the angles on the unit circle that I found. Okay? Add that pi over 4 over to get our new angles. So that is it for this video. The final question is going to pop up asking you what questions you have.